Proof by induction. This is a serious or sum example for Leaving Cert Higher Level Maths. So we're to prove that this series is equal to n over n plus 1, where n is an element of n. So we can kind of state what the conclusion is already, nearly in terms of what we want to say with the conclusion. We're going to show for the lowest value of n, that's where n equals 1. So if n is equal to 1, the first term will be 1 over 1 multiplied by 2. And we're wondering, is that the same thing as when I sub 1 in for n in the expression on the right hand side? So that's 1 over 1 plus 1. And we see it is. It's a half is equal to a half. So it works for n equals 1. Step 2 is we always assume it to be true for n is equal to k. So that means if we add up the terms up as far as term 1 over k times k plus 1, well, that will be equal to, if I put k in for n in the formula expression on the right hand side. So we're assuming that to be true. And our task now then is to prove that it's true for n is equal to k plus 1. So what we would have then is, what we're trying to prove is the sum of numbers going up as far as the last term being when I replace n with k plus 1. So the term before that is term k, and then this extra term, the k plus 1 term. Now in that, just k plus 1 is k plus 2. So that's where that's coming from. And that will be equal if I put k plus 1 in for n in the formula. So on top we have k plus 1, and underneath we have k plus 1 plus 1, which is k plus 2. So this is what we're trying to prove, that this is true. Now we're going to use the assumption. We can see that on the left hand side of this expression, we have the sum to k plus this one extra k plus 1 term. We can replace the sum to k with what we've assumed it to be, that's k divided by k plus 1. So I can replace the yellow box with the green. Plus we have this one extra term, the k plus 1 term. Now I'm going to manipulate this now, and I want to make it look like the answer we want it to be k plus 1 over k plus 2. So I want to add these two fractions together. So to do that, I have to have the same denominator. So I'm going to give the denominator as k plus 1 over k plus 2. So when I add these fractions, it becomes k plus 2 multiplied by k plus 1. Now I'm going to expand the top line. So multiplying k plus 2 by k, that gives me k squared plus 2k plus 1. And that's been divided by k plus 1 times k plus 2. If I factorize the top, I see that it can be written as k plus 1 times k plus 1, k plus 1 squared if I wish. And I see that there's a common factor here in the numerator and denominator. So the solution is exactly what I wanted, is k plus 1 over k plus 2. So I've proven what I set out to prove, QED. Therefore, I just state my conclusion. It's true for n is equal to k plus 1 if it's true for n equals k. It is true for n equals 1, we've proven, therefore it's true for all n an element of natural numbers.